Hi, my name's Atsu, also known as Squid God, and in this video, I'll show you how to start making games for the Playdate. I've made and released 9 games for the Playdate so far, so I'm excited to share with you how fun making games for the Playdate can be. There are 2 main ways to make games for the Playdate. The first one is by using Pulp, an easy-to-use browser-based dev tool. It has a few constraints, but it allows you to use a visual editor to make games with low or no code, and you can still make amazing Playdate games using Pulp, so it's a good choice for beginners looking to dip their toes into game development. This video is not about Pulp, so if you're interested in that, I'll leave a link to some tutorials I made for it in the description. The other main way to make games for the Playdate is by writing code, with the Lua programming language using the fully featured Playdate Software Development Kit, or Playdate SDK. If you're a beginner and never programmed before, no worries. I'll be walking through everything step by step, so you should be able to follow along. This video will cover how to set up your development environment for Windows, Mac, and Linux. Then, we'll make a small game together just to get a feel for how game development works for the Playdate, along with how to package up and share your game with others. Lastly, I'll be going over some resources to start looking at after this video and what next steps to take, so you can eventually make your dream Playdate game. Let's get started. The first thing that you want to do is navigate to this GitHub link in the description. The link goes to a quick start template I've created that we'll be using. All the instructions and required links are written on that page, so keep the web page open and we'll be following along as I show you the steps. The first thing we want to do is install a code editor. A code editor is just a text editor that has some extra features to make writing code easier. We'll be using a code editor called Visual Studio Code, also known as VS Code. Go to the first link in the template page and download the installer based on your operating system. Once you open the installer, just accept the license agreement, keep all the default settings, and then click Install. The next step is to download the Playdate SDK. The Playdate SDK is all the actual tools you need to create a Playdate game, which includes packaging your code into an executable and the Playdate Simulator, an app which allows you to test your game on your computer. Go ahead and navigate to the second play.date/dev link in the template. Agree to the license and download the SDK installer, which should match your operating system. As a side note, the license you just accepted has a nice summary at the top that goes over what it contains. The important parts are that 1, you completely own any game or program you make with the SDK, so you can feel free to distribute it in any way. And 2, you cannot use the name of Playdate in your game name. So for example, you can't name your game something like Super Playdate Platformer. The installation steps are a little bit different based on your operating system, so I'll go over them one by one. We'll start with Mac since it's the most straightforward. Just double-click the zip file to unzip it, and then open the playdate.pkg installer. Press Continue, then Install, enter your password, and then close after it's done. And that's pretty much it. You're done with the installation steps. You can go ahead and delete the installer zip and package files. For Windows, we have a couple more steps. You'll first want to run the exe that you downloaded and it will open the installer. I recommend keeping the default install location, which should be in the Documents folder. If you decide to change it, or if it shows a different path, for example the Documents folder in your OneDrive instead, make sure to copy and save the path because you'll need it next. Click Install and then Finish once it's done. There's one more thing that we have to do, which is setting an environment variable. To do so, go to your Start menu and start typing Windows PowerShell. Once it shows up, go ahead and click on it to open the application. We're going to run a command here, and the command can be found back on the template page under the third step, Windows and Linux, set your environment variable. Go ahead and copy this entire set environment variable command and paste it into your PowerShell window. If you kept the default installation path in the Documents folder, go ahead and keep the command as is. Otherwise, if you change your installation path, you'll need to swap out this portion of the command with your path. Go ahead and press Enter, and afterwards you can close the PowerShell window. For the 3 Linux users watching this, after downloading the SDK, go ahead and extract the zip file. Our first step is to rename the folder to just Playdate SDK. Afterwards, move it to a folder of your choice. I recommend the Documents folder. Afterwards, right-click the folder and click Open in Terminal. Type sudo./setup.sh to run the setup script. Once that's finished, we'll be setting the environment variable. Type this command to open your bashrc file in your home folder with nano. I believe there are a couple distros that use ZSH instead of bash by default, so if you're one of those distros, you would need to open the .zshrc file instead. If you don't have nano installed, you can just navigate to your home folder and open or create a .bashrc file manually. Make sure that hidden files are shown. scroll to the bottom and paste this export line from the template. If you didn't put your SDK folder in the Documents folder, you'll need to change this portion of the command to your path. Then press Ctrl X to exit Nano, press Y to save, and then press Enter to confirm the file name. With this, you should be done with the installation. Our next step is to download the template itself. On the GitHub page, at the top there should be this big green code button. Click that and select the Download Zip option. Go ahead and unzip the downloaded zip file and move the folder to a location of your choice. Now, we'll want to open up Visual Studio Code, our code editor that we installed previously. Once that's open, go over to the top left and click File and then Open Folder. Find the template folder wherever you put it and open that folder. Some unzipping tools, like the default Windows one, will create an extra parent folder. Here, you'll see that there's a Playdate template main folder that contains another Playdate template main folder that contains all the files. Make sure you're opening the one inside that contains all the files directly and not the one above it. The .VS Code folder needs to be at the top level. In VS Code, it should look something like this, with playdate-template.main at the top, and right underneath there should be the .VS Code folder. Once you open the folder, you should see a pop-up window at the bottom right that prompts you to install recommended extensions. These are required, so go ahead and click Install. If you don't see it or you accidentally close the window, you can click on this extensions icon on the left-hand side and search @recommended, and it'll show you what you need to install. The two extensions are the Lua extension and the Playdate debug extension. With this, the setup should be complete. Let's go over the contents of the template quickly. First is the README file. These are just the instructions that you see on the web page, so you can feel free to delete this. Next is the source folder. This is where all your code and all your assets like art and sound effects will go. Inside is a main.lua file that contains a small demo program that I wrote. Every game needs a main.lua file, as this is the entry point for your program. Next, this PDX-info file holds metadata about your game, like the name of the game and who made it. We'll cover more about this later when we make our example game. This builds folder is where your game executable gets placed when you're building your project. In order for your code to run on a physical Playdate, it first needs to go through a special process to package up your code and assets into an executable bundle, which we refer to as a build process. This template will automatically build your project for you and place the executable in this folder. There's a text file in here that just gives a description about what the folder is for, so you can go ahead and delete that as well. This last .VS Code folder is a custom configuration folder that tells VS Code how to build and launch your Playdate game for testing. There's some code in here that facilitates nice features like type annotations and using a debugger. You shouldn't need to touch this folder, but if you're interested in looking into the configuration, I've left some comments about what everything is doing. With the template, you should be able to go to the top and click Terminal, Run Build Task to build and run the demo program. You can also use the keyboard shortcut Ctrl-Shift-B or Command-Shift-B for Mac users to build your project. Running the build task should open this terminal window at the bottom, and after a couple seconds, it should launch the Playdate simulator automatically with the program loaded in. The Playdate simulator is an application that came included with the Playdate SDK that allows you to test Playdate games on your computer. You'll be using it a lot as you develop your game. The first time you launch the simulator, you'll just see the settings screen. This is just because a configuration folder hasn't been created yet. Usually, closing the simulator and rebuilding should show the demo app. If you're running into any other issues, there's some troubleshooting steps you can try that are listed in the template page. The most common errors are task configuration failed error, which usually means something went wrong with setting the environment variable, or a no build task found error, which likely means you opened the wrong folder. If you're still running into issues, feel free to leave a comment or join my Discord server and I can help you. Once you see the demo program running, you can try controlling the little Playdate sprite with a crank, which you can control with this wheel at the bottom. For Mac, you need to expand the dropdown to see the simulator crank controls. You'll also be able to control the simulator using your physical Playdate device by connecting it to your computer, but we'll cover more about that later. Now that we're all set up, let's try making a small game together. The game we'll be making today is a simple game where you control the player with a crank and try to dodge some obstacles. To make games for the Playdate, we use the Lua programming language. If you've never used Lua but you have some programming experience, Lua is a very easy and enjoyable language to learn, and I'll walk you through the syntax as we make the game. If you have no coding experience, that's alright. I'll also go through each step in simple terms, but there's going to be a lot of things that go over your head, and you'll end up copying pasting code that you don't really understand. That is totally expected. It usually takes a few months to understand even just the basics of programming, so take this video as a way to get your feet wet. After we finish making the game, I'll give you some resources and some tips on how to start learning to code. In addition to the Lua programming language, the Playdate SDK comes with a set of commands or functions that allow you to interface with the Playdate device itself, along with a multitude of other helper functions. This includes functions to get what buttons were pressed, ways to draw to the screen, ways to keep track of time, etc. We call the set of these functions the Playdate SDK Lua API, or Application Programming Interface. The entire Lua API is documented in the Playdate SDK documentation, which can be found at sdk.play.date. You can also navigate to it from the Playdate homepage at play.date. Click on Dev, and then inside Playdate under Playdate Development Documentation. In the VS Code folder of the template, I've included a copy of Not Peter's Playdate LuaCats library, which provides type annotations, autocomplete, and function definitions of the Playdate API taken from the documentation and displays them within VS Code. With that out of the way, let's start making our game. I've created a separate GitHub repo with the game code that you can reference to double check your work. You can find a link in the description. In order to make our game, we'll need some art for the player and obstacle sprites. For the purposes of this tutorial, feel free to use the ones I drew in the game repository. You can find them under the images folder. Click on them and click the download icon in the top right to get the PNG files. However, if you want to make your own art for the game, or when you need to make art for your future games, I'll go over what you need. The Playdate screen is 400 pixels wide and 240 pixels high. This means you'll be making pixel art for the Playdate, so you'll need some sort of pixel art program. I personally use Sprite, which is a paid software costing about $20, but there are plenty of other free and paid options, which you can find by just searching up pixel art software. Since the Playdate screen is 1 bit, you can only use 2 colors in your sprites. You can use black or white, or any vaguely dark color and light color, as the build process will automatically convert any dark color to black and any light color to white. I typically use a sort of dark and a light gray, since that's what it looks like to me when I look at the actual Playdate screen. Speaking of the physical Playdate screen, while the screen is small, the pixel density is actually quite high. The size of the screen has a similar scale to the original Game Boy, but it has around double the amount of pixels. If you use a 16 by 16 pixel sprite like in the Pokemon games, it will look very small on the Playdate screen. Something like 32 by 32 is a good recommended minimum. Once you have your sprites drawn, be sure to export them as a PNG file. Back in our VS Code project, let's make a new folder to organize our images. Right-click on the source folder and select New Folder. We'll name this folder Images. We can then drag and drop our images into the folder directly. With this, we're ready to start coding. In our main.lua file, we can delete the entire demo program. Our first step is to just draw the player. I'll leave a comment here to mark the player-related code. In Lua, any line that starts with 2 hyphens becomes a comment, and comments are just notes that you can leave in the code. In order to draw the player, we need 2 things: a position to draw the player, and our player image. Let's store our player position into 2 variables, player X and player Y. You can think of a variable as a container that stores data. The first line says store the number 40 into the variable player X, and the second line says store the number 120 into the variable player Y. For the Playdate coordinate system, the x-axis increases to the right and the y-axis increases downwards. The y-axis is probably opposite of what you're used to with graphs, but this convention is pretty common in game development. The top left of the screen is x equals 0 and y equals 0, and the bottom right is x equals 400 and y equals 240. So this coordinate of x equals 40 and y equals 120 is somewhere on the left side of the screen and halfway down. For the programmers watching, in Lua, variables are globally scoped by default. We can make them locally scoped by appending local in front of them. On top of the other benefits of managing scope, accessing local variables in Lua is much faster than accessing global variables, so we'll default to making all our variables local for this project. In order to load our player image, we'll create a player image variable and type playdate.graphics.image.new and an open parenthesis. This is part of the Playdate API. You can find this function in the documentation. This function takes one value, a path to the image in the form of a string. For the Playdate SDK, paths are always absolute. Paths always start from the source folder at the root, and you don't need a file extension. While you were typing, you might have noticed a drop-down with a list of functions. This is referred to as autocomplete, and shows us what functions are available to us in the Playdate API. This functionality is provided to us by the LuaCats library in our VS Code folder. You can press Tab or Enter to select the auto-completed entry. We'll be using the Playdate and graphics libraries a lot, so to shorten them a bit and localize them for a small performance improvement, we'll store them into variables. We can replace our Playdate.graphics call with our new GFX variable. Next, we'll need to create a required function called the update function, also known as the update loop. Everything outside of this function gets called once when the game starts. Everything inside this function gets called every single frame. By default, the Playdate runs at 30 frames per second, so we're running the code inside this loop 30 times a second over and over again. Just like how traditional animation has a frame rate and the illusion of movement is created by drawing each frame in quick succession, we'll be creating the illusion of a moving sprite on the screen by changing the spot we draw the image a little bit each frame. In here, let's draw our player image. We can do that by calling the draw function on our Playdate image variable. Make sure that you're matching the capitalization. Everything in code is case sensitive. The function takes in two inputs, the x and y coordinates where we want to draw the player at. We'll use our two position variables for that. Notice that we're using a colon here instead of a dot. When we create something with new, it's creating a new object of a specific type. In this case, it's an image. We refer to this as an instance of the image class. We use special functions on these instances called methods. These methods are always invoked with a colon. This line says, draw this specific image, player image, at the position player X, player Y. Looking at the documentation, anytime you see a colon, it follows this pattern. For example, there's this progress animator method. Since progress uses a colon, you know that you need to first create a new instance of whatever type is before it. In this case, an animator. If we scroll up, we'll find the new function to use. Then, once we use that function to create a new object, we'll call the method on that instance. This line says create a new animator called myAnimator. This next line says give me the progress of this specific animator, myAnimator. Back in our code, you should see a yellow squiggly line. This is just a warning, which we can ignore for now, but you can check what it means by hovering over it. If the squiggly line is ever red, you have a problem that needs to be fixed. Usually it's just a typo or syntax error. Make sure to save your file. This white circle means that you have unsaved changes. Now we should be able to build our project, which again we can do with Control or Command plus Shift plus B. If you're getting some errors at this step, I split up each step into its own file in the example game repository. This step is under step1.lua. You can use the website diffchecker.com and paste your code on one side and copy my code on the other side to see if there's any differences. In the simulator, you should see your player sprite being drawn to the side of the screen. If you want to increase the size of the simulator window, you can go to View, Screen Zoom. For Mac, this is under the Playdate tab and 2x Display. There's nothing going on quite yet, so let's start taking some input and controlling the player. We want to move the player by some fixed amount every frame, so we'll create a new variable and call it player speed, and set it to something like 3. In the update loop, we want to check for the crank input every frame to see if we should move the player up or down. To get the crank position, we can use the getCrankPosition function and store that into a variable. The crank returns an angle from 0 to 359.9999. When the crank is straight up, it's at an angle of 0, and it increases as you go clockwise. We want to see if the crank is in the upper half, so we can check if the crank position is less than or equal to 90, or the crank position is greater or equal to 270. If so, we'll decrease the value of player Y by our speed variable. Otherwise, we'll increase the value of player Y by the speed variable. This line reads, add the value of player speed to the current value of player Y. Take that result and store the new value back into player Y. Remember, the Y values increase as we go down, so we subtract to go up and add to go down. We can shorten this by using an assignment operator and write minus equals and plus equals instead. Now, if we build and run this, we can see it's working, but not quite the way we want it to. You can see the 3 pixel gap between the images, so we're moving the player up and down by 3 pixels each frame like we want to, but it's smearing. This is because we need to clear the screen each frame. We can do that by calling the gfx.clear function at the top of our update loop. Rebuilding should show our player moving towards the direction of the crank. Testing the crank on the computer is a little awkward, so we can actually connect our Playdate to our computer and control the simulator from our device. First, you'll need a USB cable. The charging cable that came with your Playdate will probably work if your computer has a USB-A port. If you're on a newer Mac and you only have USB-C ports, you'll need a cable that's USB-C to USB-C. In a pinch, you can use the charging cable that came with your Mac, but it's pretty long, so I'd probably get another one. After you connect your Playdate to your computer, First, unlock the Playdate, and then click Device, and then use Device as controller. On Mac, there should instead be a little Playdate icon that appears in the bottom right that you can click to find the option. Sometimes it doesn't detect the Playdate properly, so if the options stay grayed out or the icon doesn't appear, just try locking and unlocking your Playdate again, or unplugging and replugging it, and it should work eventually. When you're testing your game, you can quickly restart your game by pressing this restart icon or using Control or Command plus R. The simulator can be paused by clicking the pause button or by pressing the spacebar. Drawing an image directly works fine, but the Playdate SDK provides a special graphics object called the sprite that gives us some extra features that we want. The main thing that we're interested in here is the built-in collision system, so we can check if the player has collided with any obstacles. But there are some other nice benefits that you can read about in the documentation. If we check the sprite documentation, it says that we need to import the sprite library in order to use the sprites, so we'll add this import line to the top. There are many different systems in the SDK that need you to import a library first, so make sure to check the documentation. We'll create a new variable and create a new sprite by calling gfx.sprite.new. We can pass in our player image to set the image of our sprite. To detect collisions, we need to give our sprite a collision box. We do that by calling the setCollideRect method. Remember the colon since we're creating a new sprite instance, and setCollideRect is a method that we're calling on that specific sprite. This method takes 4 values. The first 2 being the x and y coordinate of the top left of the collision box, and the last 2 being the width and height of the box. The coordinate is relative to the sprite itself, so putting 0, 0 here means the top left of the sprite. Next, we'll just put the width and height of our player sprite to make the collision box the same as our sprite. My capybara image is 64 pixels wide and 48 pixels tall, so I'll put 64, 48 here. Sprites keep track of their own position, so we'll no longer need to manually keep track of them with the player x and player y variables. We'll change these to player start x and player start y, and move our sprite to that position using the move to method. The sprite system has a draw list that keeps track of all the sprites in our game and draws them to the screen if it's in the list. We need to call the add method in order to add our sprite to that list. In order for our sprites to be updated, we need to call the sprite update function somewhere in the update loop. We can call it at the top here. Inside the update sprite function, it includes clearing the screen, so we can remove this line. Since the sprite is keeping track of its own position now, we'll instead use this moveBy method, moving the sprite by a specified x and y amount. We don't want to move it along the x-axis, so we'll keep it as 0, and we'll move the y by the player speed as before. And lastly, since the sprite update draws our sprite for us, we can remove this draw call. If we build and run this, everything looks the same but with a key difference. If we go to View, Show Sprite Collisions, we can see that there's a collision box bounding our player sprite. For Mac, this is under Playdate, Show Sprite Collision Recs. Usually, you want to make the collision box a little smaller than the player so it feels a bit more fair. So we can do that by punching in the coordinate values and decreasing the width and height. We'll move the top left corner in by 4 and decrease the overall width and height by double that, 8, to keep the collision box centered. Once we do that, we should see the collision box be a little bit smaller. In these sorts of endless runner games, whenever you hit an obstacle, it stops the game and waits for the player input to restart. We call this game state. There are 2 states in the game. The state when the game is active and the game over state. We'll create a game state variable and let's set it to some string like stopped. In the update loop, we'll do things based on the value of our game state. If our game state is stopped, we'll draw some text with a draw text function. The function takes a string of what text to draw as well as where to draw it. Let's draw something like press A to start, and we'll put it towards the center of the screen at x equals 200 and a little bit towards the top at y equals 40. We'll then check if the player has pressed the A button with the button just press function. Then, if they have, we'll change the game state to our active game state, which we'll just call active. Every time we start the game, we want to reset our player position, so let's move the player sprite to the start x and start y coordinates. Otherwise, or else if, our game is active, then we'll run our original code. We'll move our code into this conditional block. If we build and run this, we'll start off at our stop state. Even if we move the crank, the player does not move. However, if we press the A button, the text will disappear and the game will start running. But there's 2 things to point out here. One is that when we draw the text, we're drawing it aligned to the left so it's off center. Another thing is that there's currently no losing condition, so we're never going back to the stop state. A reasonable losing condition might be if the player goes out of bounds, so let's take care of that. To center align our text, let's first import the graphics library. Then we'll switch out our draw text function with the draw text align function. This function takes one extra argument, which is the text alignment, which we'll set as kTextAlignment.center. Down in the active state, let's check if we're out of bounds. We can get the player sprite's current y coordinate by doing player_sprite.y. The top of the screen is y equals 0, and the bottom of the screen is y equals 240. So we'll give, let's say, 30 pixels of extra leeway and check if the player position is greater than 270 or less than -30. If so, we just set our game state back to stopped. Running this again should give us the functionality that we're looking for. The text is centered, pressing A starts the game, and going out of bounds kicks us back to our stop screen, where pressing A again will reset the player position and start the game back up. Next, let's add an obstacle for the player to dodge. We want the obstacle to have collisions as well, so we can pretty much copy what we're doing with the player. We'll create an obstacle speed variable, load our obstacle image. Next, we'll create an obstacle sprite with that image. Then, we'll create a collision rect, starting from the top left corner of the sprite at 0, 0, and with the same width and height of the sprite image. My rock image is 48 pixels wide and 48 pixels high. In a moment, we'll be placing the obstacle in a random position, but for now, let's just move this somewhere off screen where we can't see it. And lastly, we can't forget to add it to the drawing list. In the stop state, when the A button is pressed and we start the game, we'll move the obstacle to some random Y position. Again, since the width of the screen is 400 pixels, and X of something like 450 will put our obstacle to the right off screen. We can get a random value by using Lua's built-in math.random function, which takes in a minimum and maximum number. We'll set the minimum to be something like 40 pixels in from the top of the screen, and the maximum to 40 pixels in from the bottom. Over in the active game state, we'll move our obstacle to the left every frame by our obstacle speed. The x-axis increases to the right, so we move by negative value to move to the left. We can then check if the obstacle is off screen to the left. Let's say the x value is less than something like -20. Then we can move the obstacle back to the right side with a random position again. So we're basically creating the illusion of obstacles flying in from the right, but we're just reusing the same obstacle each time. If we build and run this, we should see the obstacles coming in from the side. When turning on collision rects, the obstacle has a collision box, but if we touch it with our player, it doesn't do anything yet. This is because we aren't handling the collisions. Let's take care of that in the next step. To start using collisions, we can use the move with collisions method. We'll call this on the obstacle sprite instead of the move by function. This takes a goal x and goal y value, instead of a relative amount like move by. For the x value, we can just get the object's current x position and subtract the obstacle speed. And then for the y value, we'll just keep the current y value. This method returns 4 values: the actual x and actual y after any possible collisions, a collision list that has data about the collisions, and the length of the collision list. Since we only have 2 objects in the game, we can just check the length value, because if the length is anything more than 0, that means the obstacle has hit the player. In a more complex game with more objects, you'll probably need to check the data in the collision list. We can just add another lose condition check here and check if the length is greater than 0, along with whether the player has moved off the screen. If we build and run the game, touching the obstacle kicks us back to the stop state. We do run into a strange bug which makes the obstacle shift out of the way if we collide into it from the top or bottom. This is because the collision boxes can't occupy the same space when colliding. We can make a quick fix by changing the collision response of the obstacle to the overlap type, with obstacle sprite.collision response equals gfx.sprite.k collision type overlap. Now, after building and running, it works like we expect. The game mechanics are pretty much finished, but let's try adding a score. First, we'll create a score variable to keep track of the score. In the stop state, when we restart the game, we'll make sure to reset the score. The score will keep track of how many obstacles we've passed. An easy way to do this is to just increment the score whenever we move the obstacle back over to the right side, which is in this if conditional block. And lastly, we'll draw the score to the screen. We want to draw the score in both states, so we'll put it here at the bottom outside of any of the state if checks. We'll use the draw text align function again, and for the text, we'll put the string score, and to add a variable to a string, we can use this ... operator. We'll draw somewhere in the top right corner of the screen, but use the right text alignment so it doesn't draw off the screen as the score gets higher. After building and running, we should now see a score count that increases as we dodge obstacles. Just a quick note about mixing sprites and regular draw calls. If you're ever drawing anything and you're not using a sprite, don't put it before the sprite update function call. If you remember, this call is also clearing the screen, so any draw call before this will get cleared. You can test this by putting the draw text call before and after the sprite update loop. Put it before and it won't appear on the screen. The last step is to slowly ramp up the obstacle speed to make it more challenging. To increase the obstacle speed, all we have to do is adjust it when it wraps around. We'll increase the obstacle speed by something like 0.2 each time. In the stop state, we'll make sure to set the speed back to our original value when we restart the game. Now, if we build and run this, we should see the speed slowly build up and get more challenging to dodge. Try playing around with different values in the code and see how it affects the game. What else could you add or change? Now that the game is finished, let's quickly go over how to debug your Playdate projects. An important part of making games is investigating your code when you have bugs. We call this debugging. One way is to simply print values to a console. Let's say we want to confirm that the obstacle speed value is what we're expecting. We can use the print function to print the value of obstacle speed. Once we build and run this, you can pull up the console by going to View, then Show Debug Console. For Mac, this is under Window and Console. Now, every time the obstacle passes, we can see the value of obstacle speed being printed to the console. Another way to debug your code is to use something called a debugger, which allows you to step through your code one line at a time. The Playdate Debug extension allows you to attach a debugger to the simulator. To do so, we first want to create a breakpoint by clicking to the left of one of the line numbers. I'll put mine here next to the line where we increase the obstacle speed, and I'll place a red circle. Then we can launch the debugger by going to this Run and Debug tab on the side. Clicking this green play button at the top will launch the simulator with the debugger attached. You can see once the obstacle reaches the end of the screen, the game pauses and something happens in our VS Code window. The game has run to the specific line of the code that we put the breakpoint on and has stopped the execution there. Now, we can actually see the values of our variables in the top left in this moment in time. You can also hover over the variables in the code to see the values stored inside. At the top, you can use this arrow pointing to the right to step over the code, which runs the next line of code. The down arrow allows you to go inside of a function on the line you're on. For example, this draw text align function. The up arrow steps out of whatever function you're in back to where you were. And pressing this continue button on the left will continue your game until the next breakpoint is hit. Clicking the red square will stop the debugger. Using the debugger makes it a lot easier to track down certain bugs. Now that we covered debugging, let's talk about how to get your game onto your device and share it with other people who have playdates. Every Playdate game needs a PDX info file, which you can find a copy of in your source folder. This holds information about your game so that the Playdate can show that data on device. The name is just the name of your game. I'll call mine Cappy Run. The author is you, so I'll put my username. The description technically isn't used anywhere, but I'll just fill it out anyway. The bundle ID follows a very specific format. It always starts with com, followed by some identifier unique to you, like your username or studio name, and then some identifier unique to the game. The bundle ID is used as a unique identifier for your game's save data. For this game, I'll use com.squidgod.cappyrun. The version number is purely cosmetic, but tells the user what version number your game is on. A common format is semantic versioning, where you increase the first number for major changes, the second number for any minor changes, and the last number for any bug fixes. The last field is the build number, which is really important because this is what the Playdate uses to see if there's been an update to the game. If you make a change but don't update the build number, any players that download your update won't get the new version. Let's say I make a bug fix. I'll change my version to 1.0.1 and then increase my build number by 1. Once you fill this out, go ahead and rebuild your game. You'll notice that in your builds folder, it automatically created a new PDX with the name of your game. We'll get back to this later once we talk about sharing your game, but let's first get the game on your device. Connect your Playdate to your computer, and under Device, there should be an Upload Game to Device option. For Mac, this should be under the icon that appears in the bottom right. Go ahead and click that, and your game should start uploading to your Playdate. After it's complete, the game will be running and you can play it immediately. Make sure to test your games regularly on device because the performance can be very different between the simulator and the Playdate. The simulator runs much faster than the Playdate, so things that work fine on the simulator might lag a lot on device. If we go back to the home screen, you'll see that you have a new sideloaded app with the name of your game. Usually, you'll want to have a custom launcher card for your game. You can specify an image in your PDX info file. Check the documentation under Game Metadata for instructions on how to do that, along with other things like a launch animation, custom wrapping paper, etc. Back in our VS Code project, let's package up our game to share. Find where your builds folder is in your File Explorer, or back in VS Code, right-click on the builds folder and click Reveal in File Explorer. On Mac, it's called Reveal in Finder, and on Linux, it's called Open Containing Folder. In our builds folder, you can go ahead and delete the game.pdx folder, since it's our old build without the updated PDX info. This entire PDX folder is actually the game executable. To share it, go ahead and compress the folder into a zip file. The zip file is what you want to share. If someone takes this file and drops it into the sideload page when logged into their account on the Playdate website, it will upload the game to their Playdate. Whenever you start a new project, we can pretty much follow the same setup steps. Just go to the template GitHub page and download another copy of the template. Unzip the folder and rename it to your project name. Delete the readme.md file and the text file in the builds folder. And then open your folder in VS Code. Click on the pdxinfo file and set your game metadata. Go into your main.lua file, delete the demo program to start from a clean slate. You're now ready to start your next project. Next, we'll go over some resources to take a look at after this video. The first stop is just the Playdate website itself. At play.date/dev, where we installed the Playdate SDK, there's a link to the documentation as mentioned before. I highly recommend reading through the documentation at some point. I know it's pretty long, but you should at least read through sections 1 through 5, which give an overview about Playdate development, and then you can skim through the API reference which shows you what functions and systems are available. Though at some point, I would say it's worth it to spend the time to actually read through the whole thing, because I barely scratched the surface of what APIs are available in this video. The next important document is Designing for Playdate. That gives an overview of best practices for making games on the Playdate. It's a short read, so you should definitely go through that. Other than that, there's a link to some community resources, as well as a link to the dev forum. The forum is a great place for any technical questions. In the top, there's also a dev help tab with some other help articles that are good to take a look at. The Playdate SDK itself also has some resources for you to use. If you go to where it's installed, there are some free fonts for you to use, some code examples, and some of the code for the SDK APIs that were implemented in Lua. Since the Playdate development community isn't very large, there's not a lot of Playdate articles or tutorials online, but there is a strong community presence, especially on Discord. I definitely recommend joining the Playdate Squad Discord. People there are very friendly, and you can always find people to chat Playdate and to get help. I also have my own Discord server, and I'm always in there, and I'd be happy to help you personally. There's a Playdate subreddit that's pretty active, r/Playdate console, which you can check out as well. There's people on Twitter, though it seems a lot of people are migrating over to Blue Sky, so you can look into those too. Next, on my YouTube channel, I have a playlist of all the tutorials I've made. Feel free to check those out to get a deep dive into topics like sprites and collisions. For those who have never programmed before, you'll need to learn in order to use the Playdate SDK to make games. But you don't have to become an expert first in order to start. You can learn at the same time you're making games. In fact, the fastest way to learn is to try making a small, simple game, something like the game we just made. And whenever you get stuck on a real problem you're facing, you learn just enough to solve that. Then you'll have a good feedback loop of motivation, which will really speed up your learning rate. However, you're still going to need to learn some more basic programming concepts, like more about the variables, conditionals, and functions that we used in our game today. For that, of course, using a search engine is your best friend, so you can look up Learn Lua. But I also have a video on my channel that covers basic Lua and programming concepts, called Learn to Code in Lua for Playdate Game Dev. For something a little bit more detailed, I wrote an entire ebook designed to teach Lua to complete beginners. I start from scratch, assuming no prior knowledge, and slowly build upon previous concepts. I've recently made a big update to the book with a lot more content and practice exercises to test your knowledge, so if you're interested, there's a link in the description. My GitHub also has all the source code for all my games on it if you want to reference some existing game code. Everything is open source under the MIT license, so you're free to reference or use the code however you like. Again, I'm always happy to help, so if you ever have a question, you can feel free to drop a message in my Discord server. Once you've made a game, first of all, congratulations. That's a huge achievement to be proud of. Now that you're ready to share it with the world, there's a couple places to do it. The most common place is on a website called itch.io. It's free to use, and you can upload your game on there for people to find. People usually find Playdate games on there by the tag, so make sure to tag your game with the Playdate tag. Another option is on Catalog, the official Panic store that's available on their website and also on device. This one is a curated store where people from Panic review submissions and have to accept your game. There's some information on the Playdate website about how to submit your game to Catalog. Anyways, that's the video. If you found this video helpful, I'd appreciate it if you subscribe to support the channel, and if you're feeling extra generous, you can also join my Patreon to support my work. Good luck, and I hope you have fun making games for the Playdate. See you next time.